the last meeting I'm doing. So for this meeting, so the throughput or the number of units of a facility can hold, receive, store, or produce in a period of time. This is called capacity. Okay. So we need to determine all these to be able to calculate the throughput. We call it throughput of the facility. Okay, this is planning over time, design new product, build or use inventory, schedule jobs. Okay, design capacity. When we say design capacity or capacity in general, is the maximum theoretical output of the system. So, for example, it applies like everywhere in manufacturing facility, in a system, in an app or something. So when you say the maximum capacity, our maximum capacity is to produce 100 units a day. The maximum capacity for this software is 2,000 users. So if more than 2,000 users enters the system, so the system will have problems. So design capacity is the maximum theoretical output of the system, and normally is expressed as a rate, percent, 2%, 10%, 20%, whatever. Effective capacity is the capacity that a firm expects to achieve a given current operating constraint, usually lower than the design capacity, because you need to give yourself a room. Okay. Design and effective capacity measurements. Design capacity ideal condition exists during the time that the system is available. Machine of Frito-Lay are designed to produce 1,000 bags of chips per hour, and the plant operates 16 hours. So the design capacity, it is designed, this facility is designed to produce 16,000 bags a day. That's the design capacity. Okay. This is how we calculate. So you take the number or the rate of production times, look here. So we have 1,000 bags per hour times 16 hours, okay, per day. Okay, so you take the hour with the hour, so you will have 16,000 bags per day. Okay, that's how it works. Another example, Frito-Lay loses 3 hours of output per day on preventive maintenance. You see how much when you have a breakdown or something, how this will affect your production. So they are, for example, here they are losing 3 hours. 3 hours means 3 hours times 1,000 means 3,000 of loss. So they're supposed to make 16,000, so they make 13,000. So they lost 3,000 bags, which is they lost money. They lost money because they have machines and facility and employee to pay when they don't produce anything. So this is they are losing money. Okay, on average, a machine Frito-Lay not running. Sometimes the machine it's not running, so 0.25 also times 1,000, which means they are losing 250 bags extra. So their actual output is 12,750. Okay. Another term is utilization. So there is something called utilization, is the percent of design capacity to the actual fee achieved. So actual output to the design capacity. So utilization is used everywhere, even, with the employee utilization, machine utilization, system utilization, everything. So when we say the utilization for the machine is 90%, that means the machine is running 90% of the time. And the rest of the time it's not producing or it's not running. The utilization of the tiller is 50%. That means 50% of the time he's working, and the other 50% he or she is idle. It's not producing anything. Efficiency is the percentage of effective capacity divided by uh, actual achieved. Okay, this is, make sure you have all these equations so to be able to calculate the utilization. It's a straightforward process. You will given numbers, so you'll be given actual output and design output, and you will be asked to calculate the utilization. And the same thing here. Okay, here is an example. Actual product last week was 148,000. Effective capacity was 175,000. Design capacity 1,200. The bakery operates 7 days a week, 3 hours, 8 hours shift. So the design capacity, we say here three 8 hours shifts. So how many days? 7 days. So you need to multiply the number of days. How many hours per day? You don't take only 8 hours. You have three shifts, right? So it's 3 times 8. They are working 24/7, 24/7. So 24 times 7, how much? How many hours in a week? I remember it is 7,000 or 8,024. Let me check. Oh, 1 second. 7 times 24 times, yeah, it's 160. The year, I mean. If you take the whole year, 365 times 7 times 24. Oh, 365, 65. I don't have my calculator. Times 24. Yeah, 8760. If they are running for the whole year, it's 8760. So design capacity is the number of hours multiplied by days. So they have to make 201,600 rolls every week. This is the design capacity. Utilization, you take what's the actual. This facility was designed to make this up to this. They cannot make more than this if they run 24/7. But actually they make 148,000. So their utilization is 73%. Okay. Efficiency is the 148 divided by 175 effective capacity. Okay. This is efficiency. So they are 84% efficient, but their utilization is 73%. Another example, this is the same, a similar example. So efficiency 80 were design capacity with said roles, expected output if they added a new line. So they added a new line. As I said, it's a straightforward process, okay? Capacity decisions impact all decisions, operations, management, as well other functional areas of the organization. Capacity must be integrated into the organization, mission, and strategy. Capacity consider forecast demand. If you have more demand, for example, next year, that means you need probably new people, new machines, okay? Find the optimum operating size, build for change, and then based on that, you make the changes. Yeah, as we mentioned, when you have a store and you have more demand, you have more customers, probably you need to decide where to go. Depends on the demand. Demand exceeds capacity, that's not good. Capacity exceed demand, you need to make some changes. It depends. Every situation, you need to find a solution for this. This is another chart shows the time and the sale unit. So for engines, motor sales, combine the two demand patterns. Yeah, we studied the forecast in previous chapters, in chapter 4. You need to match the capacity with the demand. As we mentioned, if you need more, you hear like, let's say now that X company or Z company, they laid off like 10 or 14,000 people because there's low demand. And after a few months, you say, oh, this company is hiring like another 15,000 because there is a demand. So when there is demand increase, they hire people and they buy more machine and they build more facilities. When the demand decreases, they cut the workforce. It depends, as we mentioned. Service sector, again, the same demand, appointment reservations in hospitals, in banks, everywhere, it's the same concept. So now bottleneck analysis and the theory of constraints. Each work area can have its own unique capacity. Each area, everywhere you have unique capacity. Capacity analysis determines the throughput capacity of workstations in a system. So in a system, we have like sometimes workstations. So a group of machines or people are arranged to produce a specific thing or job, produce something. Maybe it could be a code, it could be a product. There is something called a bottleneck. That's very important here. Bottleneck is limiting factor or constraints. A bottleneck has the lowest effective capacity in the system. They call it bottleneck because the flow is good from before the bottleneck, but at the bottleneck, oh, this flow is limited. That's why. So they call it bottleneck. The time to produce a unit or a specific batch size in the process is the process time. Okay. So bottleneck analysis. So the bottleneck is the time of the slowest. Again, it's the slowest workstation. When you have different workstations, like example, when you go to the bank, you join the queue, and then if you are doing like something paperwork, they send it, for example, the first step take 2 minutes and then another 2 minutes, but there is another step which takes like 10 minutes. Oh, this is the bottleneck, which takes longest time, the slowest process. Okay, so it's the slowest when the one that takes the longest. Okay, slowest means it takes the longest in the production system. The throughput time is the time it takes a unit to go through production from start to end. That is the throughput. Okay, that is the throughput. But the bottleneck is the slowest process. So this process takes 2 minutes, and this takes 3 minutes. This takes 4 minutes. So this is the bottleneck. Okay, and it applies everywhere to any process. It could be uh, like service process, production process, everything. Okay. So this is Shop provides this example from your textbook. I always advise you to use your textbook. Of course, I post all the PowerPoint slides and stuff, but it is recommended that you use your textbook because it contains more examples, explanations. So they use two identical sandwich assembly line. A customer first place an order which takes 30 seconds. It's normal. They place the order. Hello, I need two sandwiches of this and a drink and whatever fries. The order then sent to one of two assembly lines. Each assembly line has two workers and three operations. Assembly worker one retrieves and cuts the bread 15 seconds. Two assembly adds ingredients and place the sandwich into the toaster. And then the toaster heats the sandwich 40 seconds. Finally, another employee wraps the heated sandwich coming out to the toaster, delivery 37.5 seconds for that process. A flow chart of the process. That's very important. That's why, when we read the statement, we understand it, but when we have, where's the flow chart? I don't have the flow chart. I should have a flow chart. Okay, let me go back and get the flow chart for this question. S3. Okay. I remember I copied the flow chart from the textbook. Let me just get it. Oh, let's use the textbook. Here is the flow chart. And just copy the flow chart here. Okay. So you see order received here. You have, we call this parallel process, parallel. So you have parallel. So you have two identical lines, first assembly line and the second assembly line. So bread, fill, toaster, bread, fill, toaster, and then they wrap and deliver. Okay, let's analyze this process. So toaster, single slowest resources in the five, the toaster. It's 37. This is 30, but here you have 40, but you produce two. See, that's not like every 40 seconds, you have two, right? So each one takes 20 seconds actually, because you have two, okay? Every 20 seconds, you have two. Every 30, 15 seconds, you have two, okay? So this is the slowest process, okay? The solution. So therefore, the wrapping and delivering operation with process time is 37 seconds appear to be the bottleneck. That's why we call it the bottleneck, the process which takes the longest time. The slowest process is here. So you have all the sandwiches are waiting here. Okay, it's good if they add another toaster here, but sometimes, maybe it is expensive. They don't want to add another. They do the calculations and they come up that it's not good for them. They will lose money. Probably you don't know. You need to analyze this process and do some kind of simulation based on the number of customers and demand they have. But probably originally when they designed this process, it came up like this. So the throughput is 30 plus 15 plus 20 plus 40 plus 37, 142 seconds. 42 seconds. Usually we use even seconds or minutes. If we end up with 120 seconds, so we say 2 minutes. But here I probably using the seconds. Okay. So that's an example how to calculate the throughput and the bottleneck. We did that. Oh, here is the process. I have it somewhere here. That's fine. Any questions? Oh,
No questions.
no questions.
No question.
Go back. I jumped. I don't know why. Bottleneck. We talked about bottleneck already. Talked about this. So it's easy. So the throughput, you just add the lines. Okay. Yesterday I was working on the final and I put like some questions from this stuff. So from the flow chart, you can tell, oh, this is another example here, similar to the one we just did. So from the flow chart, you just add the times and you find the total time. This is the throughput and you find the slowest, but you need to notice that when you have parallel lines, or here you have 25, 24 minutes. If there is, oh, this is another example from the book, but here 5 minutes. So probably here is the bottleneck for if they need this cleaning. Okay. Okay, five-step process for recognizing and managing limitation. Identify the constraint, develop plan for overcoming the constraints, focus resources on accomplishing step two. So let me stop here 1 second. Any of you missed the quiz, chapter 17 quiz? If you missed the quiz, it's available now. You still can take it. If you did not do good and take it, so the average will count. Even if you did not do good and you feel you need to take it, this is a makeup. So if you missed it, you can take it. If you want to take it, you can. I think I have it somewhere here. So if you took it before and you take it now, I will not remove one of them. So the average will be low. So let's say you received 10 in the first quiz and you received 20 in the, oh, here is in out of 30, 30. So your grade will be 20 out of 30 average. I will not take the highest. But if you missed it and you want to take it, just take it if you want.
Will we have class on Monday?
This Monday?
Yep.
Why?
Just asking.
Yeah, there is nothing. They did not tell us that the school closed. It's not closed. But if you are traveling or something, I will do a review for what we did today on Monday, probably. If you mean because of the Is there a reason that we will not have class? The Thanksgiving is not next week, right?
I just remember you saying something at the beginning of class about this being the last topic we're covering.
Yeah, this is the last topic, but we still have more stuff to cover. We are not finishing. We still have another 2 weeks, I think, or 3 weeks. But this is the last topic, but that doesn't mean we can finish everything today. We
Okay.
still have, yeah, we still have too much here. It's not everything, yeah. Okay, any questions about what we covered today? So let me mark this. We talked about the throughput bottleneck. Any questions about that?
No questions.
No, sir.